Hey, this is page 6 of your chapter 4 reactions and aqueous solution notes. It's another example of a redox reaction in basic solutions, so one of the long ones. There's 2 of them on there. I'm going to do the second one. It's on here. Should have had another example hopefully earlier. So whenever you're doing redox, doesn't matter if it's an acidic or basic solution, first thing I do is figure out what is happening, which things are changing charge. Okay, so remember, reduction means going down in charge, being reduced in charge. So from like +2 down to 0. And oxidation going up in charge. You're losing electrons, getting rid of negatives, your charge is going up. Okay, reduction means you're gaining electrons. So remember oil rig, oxidation is losing, reduction is gaining. This isn't basic solution, so that means there's some OH negative ions floating around in the solution. Move this in maybe just a hair. You guys can see me a little closer, I'm sure you want to. So let's figure out charges first of all. This is kind of a weird ion. Okay, this is called the thiosulfate ion. Again, this would not be floating around by itself. It probably was like sodium thiosulfate. Okay, but sodium is always a spectator ion because it always is dissolved. So there would have been something else with this before this reaction happened. Probably like sodium thiosulfate or potassium thiosulfate, something like that. Oxygen charge, remember, is always a -2 unless it's the peroxide ion. So that's a -2. That means the oxygen is a total of -6 between the 3 oxygens. There's a -2 on this ion, so this must be a +4 total. That does not mean each sulfur is, but it means total those are that to get the total -2 charge. That means each sulfur must be a +2 charge. Now let's go over and figure out what sulfur's charge is over here. Oxygen's a -2, so that's a total of -8. This has a -2 charge on it, so sulfur must be a +6 there. So sulfur is going up in charge. Okay, it's not going down, it's not being reduced, it's going up. So sulfur is oxidized. That means it's losing electrons. And if we think about it, it's going from a +2 to +6 per sulfur atom. So it's losing 4 electrons. Losing 4 to go up 4 in charge. There are 2 sulfur atoms doing that. Chlorine, remember, any element by itself, whether it's diatomic or not, has a 0 charge. Over here, chlorine is now aqueous, has -1 charge. I tend to do reduction first, doesn't make a difference. So we split it into 2 half reactions. So we split into reduction half reaction and an oxidation half reaction. So chlorine is going down from 0 to -1. So it's going down in charge, it's being reduced. Remember, reduction is gaining electrons. I become more negative when I take out electrons, I go down. So we have Cl2 going to Cl -1. First thing you always need to make sure your atoms are equal, 2 and 1. The atoms that are being oxidized are reduced, not the other atoms, if there's any involved. Atoms being oxidized are reduced. And that will change our electrons. Okay, that will change our electrons. So for chlorine to go from a 0 to a -1 means each chlorine had to gain 1 electron. Reduction is gaining, but there's 2 chlorines involved, so plus 2 electrons. So these chlorines, each one's gaining an electron, becoming aqueous, was gaseous, it's now dissolved in solution. -2 overall charge over here, -2 overall charge over here. You're good. Don't have to add any waters in, don't have to add any hydroxides in, because the charge is equal. Oxidation, remember, oxidation is losing oil. Oxidation is losing. So we have S2O3 -2 going to SO4 -2. I'm just going to make a little more space there. I'm feeling I'm going to need it. So it's going from a +2 to a +6 charge per sulfur atom. Okay, per sulfur atom. So, and there are 2 sulfur atoms. So we have 2 sulfurs here and only 1 here. So first thing I do is make sure those are equal. Don't worry about your oxygens. Oxygens will get equaled out by hydroxides and waters. Okay, but your atom being oxidized has to be equal there. It's going from a +2 to +6. That's going out by 4. Okay, so it's going to be losing 4 electrons per sulfur. And there's 2 sulfurs. That's going to be losing 8 electrons. So remember, instead of writing -8 electrons over here, we show them as gaining to this side. All right. Now we make sure we can do waters if we want to, or we can do overall charge. Let's do overall charge and get our hydroxides in there. This side has an overall charge of -2. Remember, not per atom, it's the overall thing. So that's a -2. 2 times -2 is -4. And -8. This side's a -12 total. So that's a -12. So we're not trying to get them canceled out. We're trying to get them equal. So if this is -12, we want that to be -12. So we're going to have to add in 10 each negative to get this side to -12. -2 plus -10 is -12. Charge is equal. Now when we add in our waters, hopefully our oxygens and hydrogens are equal. Well, we've got 10 hydrogens here. So to get 10 hydrogens there, we need to add in 5 waters. Let's make sure our oxygens are equal. 10 oxygens plus 3 oxygens is 13 oxygens on this side. 2 times 4 is 8 oxygens, plus 5 is 13 oxygens on that side. So if your waters work out after you've added in your hydroxides, you're probably in good shape. Now we need to equal out our electrons. So electrons being lost in oxidation have to be equal to electrons being gained in reduction. So 2 electrons and 8 electrons, we need to multiply this one by 4. So I'm going to multiply this by 4, so I'm going to put a 4 out in front. I'm going to make this an 8 and make that an 8. So you're multiplying everything by 4. Make our net, okay, net equation. So anything we can get rid of, well, adding 8 electrons here, removing 8 here. Those will be gone. There's no change, there's no waters or hydroxides in this, so we don't have to worry about canceling those out. So we can just write our reaction. 4 Cl2s that are gaseous react with an S2O3 -2 that is aqueous, plus 10 hydroxide ions that are aqueous, forms 8 Cl negatives that are aqueous, plus 2 SO4 -2s that are aqueous, plus 5 waters. Remember, if you have water on this side, water on this side, or hydroxides on this side and this side, those will cancel out. All right, good luck. Kind of a lot of work. Have a good day.